In this question, I wanted to go through a 6-mark exam question about moments. So I don't know why it just cut it off, but this is a 6-mark question. It tells you this is a non-uniform rod, AB. That means that the weight does not act at the center. So we just say not at center. If it instead said a uniform rod, then we'd say that the weight is at the center. It tells you that the length of the whole rod is 200 centimeters. The mass is 15 kg, but we don't know where that mass acts because it doesn't act at the center. A mass of 10 kg is placed on the rod at point C. So that will mean that there'll be a weight of that mass multiplied by G acting downwards at C. It tells you AC is 40 centimeters, which is already labeled. It tells you it's being held in horizontal equilibrium. Now that always means two things. First of all, that the resultant force is 0 vertically. On top of that, it means that the clockwise moments about any points are balanced by the anti-clockwise moments. If this wasn't the case and the clockwise moment was larger, then it would sort of rotate clockwise and it wouldn't be in horizontal equilibrium. It tells you there's two light inextensible strings attached at A and B. Now, whenever strings are attached, there's always tension acting up those strings, but it also tells you that the tension at A is 10 newtons greater than the tension at B. That means that if you call the tension at B just T, then the tension at A can be called T plus 10 because it's 10 newtons greater. Find the distance of the rod's center of mass from A. So we don't know where that the weight of the rod acts. We know it has a mass of 15. Let's just label it randomly here. Again, I'm not sure if it is that distance, but it's just for the sake of this question. And we can say it's at a distance x from A, and we're trying to find that distance x. So let's form both of these equations. It might make sense to start by forming resultant force equals 0, because I think that allows us to find the tension. What that means is that the upward forces, tension T plus 10 plus T, which would just be 2T plus 10, are equal to the sum of the downward forces, which is 10G plus 15G, which will be 25G. In this case, you can just rearrange for tension, so that's quite useful. You can take away 10 from both sides, so you have 25G, which is 25 times 9.8. Take away the 10, all divided by 2. Now, if you guys do A-level physics, you might have used G as 9.81, but in maths, it's often used as 9.8. Now, putting that into the calculator, we have 25 multiplied by 9.8, all take away 10 divided by 2. That's all equal to 117.5 newtons. Now that we've got that tension, I'm sure it will be useful in the next part of the question. It says find that distance x, which is the distance of the rod's center of mass from A, because the center of mass is, again, where the weight of the rod acts. Let's take moments about A. We don't have to take it about A, but it just makes it easier because then we can call that distance x. Now, moments is force, or the value of the force, times the distance of the force from the pivot. About A means we're choosing A as our pivot. So this force here would create a clockwise moment. This force would create a clockwise moment about this pivot. And this force would create an anti-clockwise moment, if that makes sense. So the clockwise moments is this force of 10G multiplied by the distance of that force from the pivot, which is 40. Now, normally I would say convert it into meters, but we actually don't need to worry about that because everything else is in centimeters. We add on to that the other clockwise moment, which is this force of 15G, multiplied by that distance x that we're actually trying to find. And that's equal to the anti-clockwise moment, which is T times 200. Thankfully, we found T is already 117.5, so we can input that in now, and we can multiply that by 200. From here, we actually just need to rearrange for x, and that will give you the distance of where the, sorry, I don't know, I lost my train of thought, where the weight of the rod acts. So 10G times 40 is just 400G. So we can start by taking away 400G from both sides. Let's do that. On top of that, to get x alone, we can then divide both sides by 15G. So I'm cheating a little bit, but it's just because I don't want to just go down and you won't be able to see the rest of the question. So from there, we can take the answer that we got before, multiply that by 200, take away 400 times 9.8 because G is 9.8, and divide that by 15 times 9.8. That will give you a value of 133.2. So that means that where I've located it happens to partially be kind of right because it's more than half the distance away from A. But yeah, that's your final distance of x. It's 133.2 centimeters from position A. That's everything for this video. Be sure to leave a like if the video did help and subscribe. I'd appreciate a lot. Thanks for watching, and yeah, check out the rest of my channel. Thanks for watching. I hope this video helped. If you have any tutoring inquiries, be sure to visit my website www.excellineducation.co.uk. It's on the first link in the description too.